Quick word of caution before we begin, this power supply contains lethal voltages tested with specialized equipment. If you're not experienced in working on power supplies, I'd urge you strongly before getting into this unit. It's not worth dying over your swimming pool. Our first video kicked off with me realizing that my front panel for the pool pump had no power. I tested mains voltage, which was good, and the output voltage to that panel, which was acting really flaky. So I started disconnecting things and noticed there was water in the electrical areas. So the pump was deinstalled, rinsed off, and dropped on the dining room table for further disassembly. There it was discovered water got into the rear portion of the power supply, and one or more components on the power supply board was damaged as a result. Testing was done on the protection circuits till I was confident that low voltage AC could be applied. Then through a variac and an isolation transformer, AC was used for troubleshooting. It was determined that everything was good at least up until the rectifier and DC filtering, and an internal regulator on one of the ICs allowed for further investigation. Using a temporary capacitor, I found everything good up until this portion of the switch mode power supply, and the oscilloscope demonstrated on output that it was going into overload protection due to a possible short somewhere. I chose the biggest drawer with the largest heatsink as the likely culprit, and pulled its 15-volt VCC leg out of the power supply circuit. After that, the power supply started behaving correctly and displaying the proper output, as well as the 12 volts that can now be seen again that goes out to the display. I left off that video waiting for this new IC to come, as well as the correct capacitor. It's going to look like I'm working this repair backwards, but things are going to start to make sense. I need to work in this piece first, and I'm going to remove this mastic-like material before I start the cleaning process. It's kind of like a clay, but it doesn't harden, at least not on this side where there was no water exposure. This side it turned into a rock and just crumbled. I'll hit the area with a kitchen cleaner that I have on hand, and then I'm using a metal bristle brush, a really tough brush, to get all of that oxidation off. After some scrubbing, I'll do a rinse and check on the progress of my work, and clearly it's going to take a couple of intervals. But each time we're getting closer, and it won't be long. After 20 minutes, everything is perfectly cleaned. While that's drying, I want to try and address this broken screw right here. I'll hit it with some penetrating oil. And there's barely enough room to cut a slot in this thing, but I'm going to give it a go anyway and see what I could do. And it looks like I may have one. So it's going to be heat and then percussion and then screwdriver to see if I get lucky on this stud. And I tried like 4 different cycles, and each time I made this weaker and weaker, so I had to go with plan B eventually. And that meant just flattening everything off so that it's flush, so that I could retap the hole. And everything started off really good with the pilot bit, but I did not realize that I was drilling in an awkward position because of the camera in front of me. And as I proceeded, it was already too late. The bit was fatiguing. That's it. Show's over. Bits in the hole. There is no easy way to fix that. That is not meant to have a screw anymore. I left this mistake in the video that others might learn from it. Continuing on to the next task, I'm just going to clean the top of the motor case right quick. While cleaning, I noticed that seal is on the way out. A closer inspection, the seal shows that this will need to be addressed. This is bad. Here's the mating surface on the other side. So now I'm going to lay this piece, long since dried, back onto the motor housing, where we could get a good look at it before it's treated. And I'll be using inox in the untreated metal. This will only be of benefit for areas that already were oxidized, so I'm only doing it on the left side and the front area. And this will sit just like this overnight, undisturbed. Some opportunity cleaning before assembly. This fan with all the caked up dirt on it, not only to remove the dirt, but to help obviously with the balancing as the dirt accumulates. So I just brush it off after spraying a detergent on it to loosen all that dirt. Then I wipe everything off with a towel. It's just got to be clean. We're not eating off of this, but it's just how often do I get to clean this fan? Next, of course, I make my way to the garage where the fan shroud will be cleaned with soap and water using a nylon bristle brush. It's not too bad, so it really doesn't take long to clean this thing. These are all just targets of opportunity while you're in the unit to make sure everything that can be cleaned is cleaned to the greatest possible extent. Who doesn't like a shiny fan shroud? I'm going to put RTV over where that broken screw is, predominantly to reduce the chance of any noise from vibration. So I'm just going to lay a bead on here and just distribute it around with my finger. I then put some on its counterpart inside the cover. The cover is then carefully placed back on and aligned over the holes. Anti-seize is used on the remaining 3 screws to ensure that the screws don't break again. Anti-seize gets pretty messy, so I use gloves as I distribute it evenly onto the threads. And as I turn the screw in, I make sure I turn it in and then back out and in and out to evenly distribute it on the threads inside the unit. And then I repeat this process again on the remaining screws on the bottom on this side, and then finally this one. All 3 screws are then snugged down with the flathead screwdriver. A little RTV is then applied to that remaining 4th screw hole, and then it's dressed off. Finally, the shroud is cleaned up to remove any residual RTV and anti-seize, bringing it end to this portion of the project. The same RTV is then used around this connector where this old gasket used to be. And then some is also applied to its mating surface. The 3 screws holding in this piece also get anti-seize. The piece is then laid down, aligning the screw hole. And the screws are then installed, starting with the center one, and they're loosely fitted, allowing the other 2 to be aligned up before the tightening procedure begins. So that one goes in, followed by the one on the left, but only a couple of turns to get it going. And then the one on the right, a couple turns on that one. Now the center one can be tightened down. Not too tight, it's into aluminum. And then progressively tightening down the left and the right ones back and forth until they're snug. This piece is now secured to the motor housing. The excess oil that was applied to the aluminum can now be wiped off. And looking back at what this piece used to look like with the damage, this is an amazing recovery. The old thermal tape is now pulled off of this piece. This was for that chip, and this was for the rectifier. It leaves a residue behind that we will clean with acetone, and I'm going to take my time to ensure that all of this residue is completely removed. We're not going to be using thermal tape, we're going to be using paste on the rebuild. So I want this absolutely clean, and I'll probably clean it once more in the final assembly, but I want to see what we're working with. And this is machined perfectly flat, as you see. Very nice. I'm taking a minute to clean these 2 drain plugs so I could install them because I don't want to lose them because they're small parts. Jax 327 will be applied to the O-rings. And not a ton of this stuff is needed, just a thin coat. I put way too much on my finger, ultimately wasting it. But I'm just going to put it on both of these. Spread it around evenly. I'll use the other side of that brush to clean out any grass and debris that's stuck in these holes. And then I'll just snug down both of these plugs, that'll be it. And that way I don't lose them. I might as well do the other seals while I'm at it, waiting for some parts to arrive. So I remove this first one. And I'm mixing some vinegar with some water, 50-50. I drop the seal in for a couple minutes to loosen these mineral deposits and the old lubricant on the seal, scrubbing it with the brush to clean it off. And then I'm going to wash it in some water and soap and let it dry. And then I'm going to reapply the Jax 327 onto the seal, a thin coat, completely coating it. And then I'll place the seal right back in after I brush out this recess to ensure there's no dirt in it. And there we go, there's one seal done. And I'm just going to repeat that entire process on the seal on the top. There's no difference, and we're done with that. One more is the one under the cap, which I gently pry out from the cap. And I'm going to wash both the cap and the seal. And now I'm going to coat the seal and reinstall the seal into the cap. I've washed out the basket. I place it back in. And we'll just put this cover right back on. And we're done. Here's a logic board or computer for the unit. Here's our connector. I'm going to place this back in. I removed it for testing. I line up the holes. And we can see there's the connector for the remote unit. At this time, I'll take some deoxit D5 and spray it on those 4 connections going to the motor. This will both deoxidize it and make it easier to connect and disconnect those fittings. The rectifier still has the residue from the thermal tape, so I'm going to remove this with acetone, being very careful to only get acetone on the top of the rectifier, as the acetone could damage anything on the circuit board. And now it's clean. I'm not concerned about this chip, obviously, since it's about to be removed. The next step, I'll use my desoldering pump. This is a cheap pump and splatter style desoldering pump. And I go over the pin, heat up the solder, spin it around in a circle a bit with the flux that I applied, and then hit the button, pull up the solder, and then release the button to spray it somewhere else. And I repeat this. And I realize it's not turning out exactly like I wanted. We're going to find out why in a bit. I would have changed up the order had I realized. But now I stop and I apply more flux to these pins over here, and I continue on with the same exact process. The problem is I end up having to come back and use a soldering iron to actually pull out each pin individually. So the old chip does come out, some of his legs laying on the bench. Now removed, we can see that there are pads on both sides of the board, and my solder socket cannot remove the solder through there with the pins, so that's why it was difficult. But now, with it removed, I can now add solder, which seems counterintuitive, but I add a bead of solder, and with that, I can heat it up and pull through the solder with the sucker to clear both pads. I'll demonstrate one more. And I'll repeat this on all the obstructed ones. I look up and inspect through a light. I can see that all the holes are clear except for 24, which is never used and always plugged. Now done with the desoldering, I'll take some alcohol and clean up all the flux and mess that I made. Do a quick inspection, then I'm satisfied, and then flip the board over and repeat. And I'll wait for the IC to arrive. I ordered from this company. They have me waiting 6 weeks, and then 2 days before it's supposed to arrive, they send me a refund with no answer, and no answer to my question as to why they did that. Terrible company to deal with. So I had to start all over and order another one from eBay, and there was no problem. The eBay one haven't arrived. We're going to unpack it, make sure everything looks good, and install it. Take a minute to confirm that the part number is the same as the old one, which it is. And now I'm going to lay it down into the board. I'm going to have to line up all those holes so that it seats in properly. Once aligned, I do temporarily put a couple of sheets of paper between the chip and the board to make it stand off about 1 millimeter or so. Then I secure everything together temporarily with a big piece of masking tape. I know that there are connections on both sides of the board, and I want the solder to flow through both sides, so I'm putting a generous amount of flux on all the pins to make sure that that happens. Then I'll solder in the 2 opposite pins just to anchor the board into position. Also, I'll be checking that the solder flowed through properly and that it was sufficient. Furthermore, I'll remove the couple of pieces of paper between the IC and the board at this time. Now I can continue soldering all the rest of the pins in the exact same manner. Tweak a couple of the connections on the other side where it looks like the solder came through a little too much. Just touch it with the iron, settles them down. Now I'll clean up the mess I made with all the residual flux on the board by using alcohol to clean it up. This is the big moment. And we got light with the chip in, so it looks like we're good, but we're going to look at the rail, and we are seeing 15 volts, so we may be out of the woods yet. This test capacity here has served me well, but I'm going to need something a little more permanent. Looking at the documentation, my specific chip would never have called out for a 10 microfarad capacitor, and I couldn't see an electrolytic being a 0.1, so I'm going to settle between 1 and 5 for now. Also, because I have a 4.7 on hand that's rated, and I don't know what the actual value is. If somebody does know, yeah, let me know. But I'm going to remove this old capacitor. Prepare the pads again on C6 for the new capacitor. This is fresh solder, so I'll be able to just solder this right in. No problem at all, as long as I observe the polarity, but there's an actual shape and outline. And we can see everything installed just fine. So I'm going to rerun everything again, just as I did before. And we see the light come on. Then I'll check the 15 volt rail again. And we're looking good. Here are those two original balls of clay or mastic or whatever that I kept. And I also have duct seal that I'm going to use. And I'm just going to take out an amount. And obviously this is going to be hit and miss. So I'm going to make a ball out of it. If it's too big, I'm going to keep taking off stuff until I get the right size. That's too big. So keep going. Eventually I'll get it. And that looks about right. And these will replace the 3 that were rotted away by the water leak. So I'm going to press these 3 new ones into position on the capacitor side. This is the side where they were destroyed. The 2 white ones were undamaged and they'll go back in their original position by the coil. The capacitors still have the yellow tape, but I lost the tape on the coil, so I put some Super 88 around it. And for the next step, we'll be using some heat transfer paste. I can't see this once I apply it because the board will be connected and I don't know how far it presses, so I am using an abundance of it. And I think caution is a good idea here. And I'm doing the same thing on this IC as well, because again, if it smushes out, that's fine, but if there's not enough, these ICs are going to prematurely die. And we can see I'm laying the board down. I won't be able to inspect how good these connections are. That's why I use an abundance. And the first thing I'm going to do is push in these 4 connectors in the front middle here, so I don't induce any stress on the board. So I'm going to seat those in first. And now I have to sort of massage those clay pieces where the capacitors are down. Not so much on the coil because it's softer that side, but this capacitor area, I have to keep sort of smushing it down until the screw holes on the board are flush. Just like that. That should be good. Next, I'll reintroduce the 5 screws that hold in the circuit board, but I won't be tightening them down, just installing them. That way the circuit board's able to wiggle around a bit. And the reason why I want it loose is because I have to install these screws. This one here is the single screw for the rectifier. And these ICs can be moved very slightly in a given direction as needed to get the screw to line up. And then we have 2 more screws that hold our new IC into place. So we're screwing those in now, not tightening it down until both screws are in. And I can see through the hole in the circuit board that as it tightens down, the thermal paste is squishing out a bit, which is a good sign. And at this point, I could tighten all 3 of them down. And this is followed by the tightening of the 5 screws that hold the main board into the chassis. I've chosen black RTV for the next step because it's watertight and removable. And what I'm doing is I'm going to make a bead around the entire perimeter of this box, which will get a little bit messy. I'll have to clean it up afterwards. But right now, the important thing is just making that bead, and then I'm just sort of evening it out with my finger, which is quite messy again, but needs to be done. The cable for the other circuit board is now plugged into our main board. And the top cover is laid over into position onto the RTV that was just applied. Pressing down to make sure that it's in the notches properly, some of the RTV smushes out the side, removing the excess with my finger. I take out this special security bit again that I used to put the 4 screws back from under. Start it again by hand. Give it one last cleaning and it's time for sea trials. I don't want to run the pump dry for any length of time, obviously, so I'm going to connect everything up as normal. It's just these two connections right here I have to tighten down. Only takes but a minute to do so. Once these are tightened down, I'll focus my attention to the electrical connections, which I am connecting outside the pump for the initial testing. I'm not going to go through the Liquitite, so these are just going to be screwed down enough that they're not going to come out, but obviously this is just for test purposes, the way that I'm connecting these up. The ground I'm going to connect outside the box right here on the ground post, connecting both the earth coming up with the green wire to satisfy that requirement. I accidentally misplaced my little connector, so I wire wrap the wires as you would do on a telecom frame. This should be satisfactory for testing. And that's it. This is the big moment. All or nothing. I'm turning on the breaker. And there it is. The box turned on. That's a good sign. Let's see if the pump turns on. And I'm running over because I'm excited to take a look, and I'm not running my camera, but I'll come back and run my camera in a minute. It is going to prime, so I'm running back with the other camera to see it priming, so it's looking good. But obviously there's zero water in this system. It's not going to prime when there's no water in it, so I'm going to have to shut this down after this initial smoke test while it's running at maximum speed. But everything's looking good, but I don't want it running indefinitely like this without water. Hitting the stop button from the front panel shows that we have good interaction with the panel. And I'm shutting the breakers to add water only because we have exposed AC. I generally wouldn't do that. But I'm going to crack open this filter here and just fill it up with the hose. Lock everything back down, and we're going to give this another go. Just give it a couple taps, make sure it's tight. Fire in the hole. Turn the breaker back on. I'll speed up the priming portion, but as expected, it's starting to prime, but it's designed given the amount of time that I've set up for priming when there's not so much air in the system. So we're going to need a second priming to get this underway. So very easy, I'm just going to hit stop, and then I'm just going to hit start again, and it'll reprime, and we can see what happens now. Now we're seeing good priming with all the air being purged from this filter unit. And we can now hear the pump running in normal operation. This is currently, for me, like speed 2 that would come up on this time of year. No strange noises. Now that the fan is cleaned out, it sounds brand new. This sound and looks like perfect operation of this pump right now. Let me just purge the air from this filter. And that's good. This is definitely the outcome that we were hoping for in testing. Going through the other speeds, trying speed 1. No surprise, that is really quiet. Working good, very smooth. That's like a wintertime speed when we're not using the pool. Speed 3, something I'd never use on schedule. If I had like cloudy water or something, I would use a speed like this to accelerate its cleaning. And this sounds good as well. Looking very good. Speed 4, again, something I would never use on schedule. This would be for priming or a cleaning event. But again, this sounds good. Seems to be operating without issue. I realized I did have enough salt in the pool, but the power's been off for so long that the cell type had reverted back to 3, the default, and I just needed to set it to 15. So I've got this little adapter now, and it's time to put all the wiring back into the pump and close everything up for good. So we're going to start with the Liquitite. And our AC connections. Followed by the earth connection. Bring our house ground in from the bottom of the pump here. Tighten it down, then secure it with the screwdriver. And I have dielectric grease that I'm going to apply to both ground fittings so they don't oxidize. Now my remote wires be screwed onto the connector, and then the connector be installed onto the circuit board. Because this cable coming through here isn't liquid tight, I thought maybe it's a good idea to apply some RTV here. It is possible some of the water could have gotten through this fitting. The top cover is then placed back on, aligning the 3 screws. First finger tightening to make sure that they are aligned. They're then torqued down into place. Finally, the blank cover is placed over top and it is secured down with the 2 screws. This completes the project. In the end, it cost about $30 to save over $1,500 using just a little bit of know-how and employing the following. Observing safety precautions and not getting yourself killed over a swimming pool. Ensuring the electrolytic capacitors have been given ample time to fully discharge. Using isolation power supplies and variacs for added safety. Being methodical in the troubleshooting approach. And exhaustively research the documentation. And that concludes this series on the repair of this Hayward variable speed pump at the component level. I hope you found this video enjoyable, entertaining, and informative. Do me a favor, hit that like button down below, helps me out a lot when you do. And hit that subscribe button for more videos like this when they come out. If you have any questions about this pump project, or you know the size of the capacitor, or anything else you'd like to share, leave a comment down below. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?